We are on page 178. We're in 3.2, problem 3. All right, here we go. Ticket sales. We were going to a football game. There was a student ticket price and an adult ticket price. Sam, you're a student. How much does it cost you to get into their high school?
$5.
Thank you. Wyatt, you're an adult. How much does it cost to get into the... Sam's going to pay $5. You're going to pay $10. Okay? Why do they do that? Do they really think adults are richer than students? I don't think so. I think I'm poorer than my kids. But here we go. It is what it is. Students want to attend. Oscar, could you read for us?
Students that want to attend the special game must purchase their tickets at school prior to the game. So far, 189 students brought tickets for the game. The Athletic Association wants to know how many athletic tickets they must sell in order to reach their goal of $3,000. However, they want a method to make forecasting how many adult tickets they must sell more efficiently.
Okay, so we know how many students bought their tickets. Put a box around that, please. We know how much money they want to make total. Is that just student tickets in that $3,000? No. They want students and adults total to be $3,000. And so they sell the student tickets ahead of time, I guess. And they're trying to drum up enough adults to come to the game to make the amount of profit that they need. Another way to determine. Christian, could you read, please?
Another way to determine the number of adult tickets that must be sold to reach a goal of $3,000 is to transform the equation to isolate the first.
Isolate A, the variable that represents atoms. So here's our equation. They are only, in this special question, interested in A. They already know S. So they're subtracting 5S from both sides of the equation. They show it actually right here and right here. So they've moved that 5S away. Now they have 10A equals negative 5S plus 3,000. And now they divide by 10, divide by 10, divide by 10. So this is the same exact equation as we've been working with. We've been working with this equation, but now they want to get one variable by itself because they have a question they want to answer, and that's about the adults. So here we go. Here's our equation. How many adult tickets must be sold to reach the goal of 3,000? Okay, so we have A equals negative 1/2. Am I too low? Yeah. Okay. I've got an S right here in my equation. Where's that equation? I'm going to use this equation now to answer some questions. A equals negative 1/2 S. What am I going to put in instead of S?
189.
189. In this instance, I know about 189. I'm multiplying it times a fraction, so maybe we'll put that over 1. I don't know if that's helpful. Okay, again, Anna, where did they get that 189? From the students, because in the equation, that's the S. The rest of it is negative 1/2 189 plus 300. All right, you have calculators. Go ahead and do that. Turn that calculator on. I've got A, all I have are numbers. I do have some fractions, and I do have a negative. See what you can do. clear, mode, clear, clear. Plug some stuff in. You can look at it like this. Yes, so I kind of gave you a hint about one way to approach it. Put that over a 1. Negative 1 times 189, 2 times 1, multiplying fractions, but we have a calculator. All right. What are we getting for a total? I'll do it.
205.5.
105.5. 105.5.
Okay, I'm hearing two tables that agree. Okay, 205.5. Now, wait a minute. That is the adults, and that's the math of it. Can you sell a ticket to half of an adult? Okay, so sometimes in these kind of problems you get a number like that, then you have to think about the situation. This is the first answer, but I'm going to put a second answer of 206. Because if I sell 205, is that enough? No, just barely not enough. But if I sell 206, I'll make it. Okay, number 2. Yeah, that's not a good seat for you. It's not your normal seat. I let you sit there, but it's not working out. No. Guillermo, could you read number 2 for us, please?
Let the x-axis represent the number of the students' tickets sold. Let the y-axis represent the number of adults' tickets sold. Determine the x-intercept and the y-intercept for the transformed equation. Explain what each intercept means in terms of the problem situation. What do you notice?
Oh, okay. So that number 2 is, I think it'll make more sense if we look over here at what's going on in number 3. So in number 2, they're asking us to look at our equation. A equals negative 1/2 s plus 300. And think about what an x-intercept means and a y-intercept means. Okay, so I'm looking at what they have written here, student tickets and adult tickets. What do you think that tells us? What do you think that tells us? Who's the x-axis, students or adults?
Students.
I think that tells us that the students are the x-axis, okay? And that would make sense because right here, this S is kind of in the place where X's are a lot of times. And I think this is the y-axis is the adults because they have the adults going sideways. So, in this equation, what would be the y-intercept? Y-intercept is on the y-axis, okay? And I already hear some people saying it's 300. Let's go ahead and plot that. 300 is right here. It's going to be on the y-axis, and it's 1, 2, 3 up. Because I can see that that's 400, and they're going, it appears each box is 100. Okay, but again, question number 2 asked us to interpret that. So y-intercept is 300, but what is that in terms of adults and students? Okay, so adult tickets is y, so that's 300 adults, right? How many students is that? Y-intercept is 300 adults. If you're right here, how many student tickets did you sell? None. Because if you look at the student axis, are you to the right?
No.
Or the left? No. In the student, in the x-axis, you're right in the middle, and right in the middle has a value of
300.
0 for the x-axis. And x, we said, is students. and the Y we said is adults, based on what we're seeing right here and right here. Okay? So right here, this y-intercept we know from the equation is 300. We know how to put that on a graph. What that stands for is 300 adults and 0 students. Okay, now something that they're talking about too is x-intercept. This was y-intercept. Let's think about x-intercept. We're going to have a line that's going to go like this. We have negative 1/2 s. That would be down 1 to the right 2. Let's do that again. Down 1 to the right 2. So I used my slope, the way we've been using slope, to get a line. Because x-intercept, I need to see where this line crosses the x-axis. You guys need rulers? Here we go. Couple rulers. Go ahead and share. Couple rulers. Doing this quick, so do a share. Couple rulers. Some tables this may be dangerous. Yes? Okay. Now, you've made a line, yes? First thing to notice. The first thing we were looking for, Andy, is the y-intercept, and that we could see was at 300, because we know if we have it set up in y equals form, that 300 is all by itself over there. But what we're trying to look at is, oh, that's 300 adults. But at the same time that we know about adults, it also represents 0 for students. Because if I look down to the student axis, we're at 0. Now, I did my slope to find the line. Where does it look like it crosses the x-axis for us?
Probably about 600.
Okay, so mine crosses right about there. Did I not draw a very good line? Is yours crossing at 600?
Yeah.
Okay. Yes. Let me fix my line a little bit. Okay. There we go. That does look more like 600. Okay. So x-intercept happens when x equals... Is it off to the side? There we go. What? Are you talking to me? Okay. Where's my pink? Here we go. So x-intercept, hello, is where it crosses the x-axis. X is 600. That means students equals 600. What do adults equal?
300.
No, right here. At this spot, they do for the intercept 0. If I am at this big pink spot and I look across to the adult value, right there is 0 because we're not up or down. Student tickets equals 600. Adults equals 0. Thank you. Okay. I need your attention up here, and some of you that means put down your ruler. carefully. Now, what do you notice? X-intercept, Y-intercept. Adults on this side, students on this side. 0, 0. What's happening at an intercept? Yes.
There's always going to be one part of the line which is on 0.
One part of the line is on 0. Can you imagine, Andy, a game where only students go?
Yes.
Yes.
All the adults stay home.
Yep.
Yeah.
Like a game maybe during the day.
Yeah.
Do we ever have games during the day where we go watch, where we can think of hypothetically one, we go watch and no adults come?
Yeah.
Okay? Can you imagine a game, probably not around here, we love our games, but where no students go?
There's no game without no students.
Okay? Well, no students go as crowd. Just parents. Parent only.
Yeah.
I mean, it probably wouldn't happen in Tamales, but you can see how that might happen. That's what's happening at these intercepts. This is a value for only adults. This is a value for only students. Most of the time, we're somewhere else along this line. We have a combination of a little bit of adults and a little bit of students. That's what this line represents, different combinations of adults plus students. But the intercepts are the two extremes. Okay, number 4. Slope of the graph.
I already did that.
Good, what is it?
Negative 1 over 2.
Negative 1 over 2. Now, interpret. Interpret. If we're going down 1, that means we're going down on the adult axis. Down 1. Excuse me. Jeremy, go ahead and move right now. Come right here, please. Down 1 adult. What does the over 2 mean? Is to the right.
To the right.
Is the right an addition or subtract? No, right here, Guillermo.
Oh.
Okay. Down 1 is minus 1 adult. Okay, or minus 1 box of adults. Down 1 adult. What does the over 2 mean? 2 students. The left and right are the students. Down 1 adult plus 2 students. Okay? So that means if I want to make money, for every adult that doesn't come, I have to sell 2 more student tickets. Does that make sense? What was the price of adults? What is the price of students?
5.
Ah. So if I want to make the same amount of money, anytime I have 1 less $10 ticket sold, I got to sell 2 $5 tickets. All right? Let's see. Athletics. Let's take a look at number 5. You go ahead right now. Work at number 5 at your table. I'm going to walk around. Talk to the people at your table, please.